Hello students, I welcome you back to study session 4 of Physics 101. My name is Adeoye Olasunkanmi, so I'll be the one to take you through study session 4. Learning outcome for study session 4. So it is expected that after we have completed this study session, you should be able to understand very well the concept of center of mass and center of gravity. So you should be able to understand that concept very well, and you should be able to explain moments of a force. You should be able to define a rotational motion and apply it in solving practical problems, and you should be able to explain angular momentum and torque. Then we'll define the concept of total mechanical energy in the body. So when we are through with our discussion in study session 4, you should be able to apply this concept in your day-to-day activity or learning. All right. In order for us to understand very well the concept of movement of a body, there is need for us to understand what center of mass is and what center of gravity is. So there is need for us to have an in-depth understanding of it. Now, when we say center of mass and center of gravity, they are they are two important concepts in physics, because the understanding of center of mass and center of gravity help in solving engineering problems, in solving in applications, engineering applications and all that. Now, although those two terms they may sound similar, they have different meaning and uses. Now, when you talk about the center of mass is the point where an object's mass is evenly distributed. The point where an object mass is evenly distributed, that's what we call center of mass. And it is the average position of all the parts that make an object. Now, let me give you an example. When you have a ruler, you know a ruler is a straight line. If you balance that ruler on your finger and it remains stable on your finger, we will say at a state of equilibrium. The point where the balance is called the center of mass. Now, this is because the ruler's mass is evenly distributed along the length of the ruler. So at both end points, it is balanced. So that is how we are able to identify center of mass. Now, on the other hand, the center of gravity is the point where the force of gravity acts on an object. It is the point where all the gravitational forces on an object can be considered to be acting. So the gravitational force of an object where it is acting, that is where we call center of gravity. Now, let me give you an example. When you take a pencil and you put it on a table, not lying on the side, I mean a straight line. You know, once you remove your hand on it, the pencil will fall. So the point where it falls is the center of gravity. Where it falls to, that's where the center of gravity is acting. So that is what the center of gravity is. So this is because the force of gravity, it pulls the pencil towards that point where the center of gravity is acting. So in most cases, the center of mass and center of gravity are at the same position, but there are some peculiar situations where the center of gravity and center of mass are not the same. This happens when an object is not in a uniform shape or they are not of the same density. For instance, when you consider a seesaw, as you are seeing on the screen, this seesaw, when you have somebody that is very that is heavyweight on this side, and you have another person that is of much lesser weight on the other side. So when they both sit down on the seesaw, you will observe that the seesaw will tilt towards that person that is weighty. It will tilt towards the person's side causing the center of mass to shift towards that person because it's more heavier. So it will be the one to receive, it will push the other person towards the side because the mass is on his side. So that means that the center of mass will have shifted towards his side. However, the center of gravity will still remain in the middle of that seesaw. The center of gravity will not change. So which means mass have effect on that seesaw, thereby deciding where the seesaw will tilt, and that caused the center of mass to shift. But the center of gravity, where the gravitational pull is acting on that seesaw, did not change. Now, if you are able to understand the difference between center of mass and center of gravity, it will help in our day-to-day activities and in deciding some things, especially in calculations. You see, engineers, they use this concept in designing structures. That is why you see some buildings that they will have a tiny base, yet they will have a heavy load on them, like Burj Khalifa Hotel in Dubai. It's the concept of center of mass and center of gravity that was used in designing that hotel. That is why it is stable. Under so many external forces, it still remains. So center of mass and center of gravity help objects to have stability. Also, astronauts, they also rely on the principle of center of mass and center of gravity to explore space. When they shoot satellite into space, it is the concept of center of mass and center of gravity that help them to stabilize all those things in space. And the figure you are seeing here also, the figure is showing some regular object that we have, and is showing where their center of gravity is acting. Like this circle, the center of gravity is at the middle. You see this triangle, you see where the center of gravity is, and these are rectangle also. And so that is how to get the center of gravity of the object. Now the next one we'll be discussing about is the state of stability in a body. What do we mean when we say state of stability? Stability in a body refers to its ability to return to its original position after it is moved slightly. Before you talk about stability of an object, you have to talk about the object being displaced by an external force. So when there is any light external force acting on the body, if the body is able to return to its position or not, that is when we are talking about stability. And in physics, there are three states of stability a body can possess. The first one is stable equilibrium. When we say an object is in a stable equilibrium, it means that when there is a slight push or pull on the body does not fall. The body returns back to its initial position. Like you are seeing in the example here, you see this example is said to be in a state of stable equilibrium. And when we say the object is in a state of unstable equilibrium, what do we mean? An object is in a state of unstable equilibrium if when it is slightly disturbed, it tilts and fall over without returning to its initial position. So when there is a force acting on the body, it will not return back to its initial position. It will fall off. It will fall off. So, and when it falls off, say it's not in a stable equilibrium. So, like this, we will say it's not in a stable equilibrium, like you are seeing on the screen. And the third one is neutral equilibrium. When an object is in a state of neutral equilibrium, when an external force acts on it, it will not fall, and the position of the center of gravity is the same. It is not affected. So you just see example of such objects, round object that will just be rolling and moving around. as it is shown on the screen here. You can see it. So now there are some things that need to consider when we are talking about stability of an object. Stability is directly proportional to the weight of a body. So a heavier bodies are more stable. When you see a heavy object, you see when you put it down, it will not fall. Yeah. In addition, stability is indirectly proportional to the distance of the body above the base. So what this is saying is that the higher the distance of the body above the base, the more unstable the object will be. So when you lower the center of gravity of an object, the object becomes more stable. For example, when you have a car and an SUV, uh, you will observe that an SUV, there is a high chance for an SUV to turn over compared to a car, because an SUV has a body that is higher than the center of gravity compared to a car, which is lower. The body is closer to the ground, closer to the base. So a car have more stability compared to an SUV. So it is recommended to increase the area of the base and lower the center of gravity of a body if you want it to be a stable object whenever we are designing or doing something in that line. Okay, the next topic we'll be considering is moment of a force. In order for a force to develop a moment, the force must act upon the body in such a manner that the body would begin to twist. A moment is the turning effect of a force around a fixed point that is called pivot. Now, you see on the screen, at this point, this is a fixed point, this is what is called pivot. A force is acted upon this spanner. Now, when this force acts on this spanner, it begins to twist. Now, when it begins to twist, we say a moment of force has occurred. So the size of the moment of force now depends on two factors. When you see something like this, for a moment to occur, two things must happen. Now, the first of the factor is the size of force that is acting perpendicular. If you observe that the force that is acting here is perpendicular to this object. So how heavy this force is, or how much of this force is being applied to this spanner, will determine whether a moment will occur or not. Another thing that will cause a moment to occur is this perpendicular distance. The longer the perpendicular distance, the faster or easier a moment occur. Now, a formula for calculating moment of a force is force that is applied multiplied by the perpendicular distance. This formula is very important because as you progress in this work, you will need it. So in order for a force to develop moment, the force must act upon the body in such a manner that the body will begin to twist. So when you are asked to define a moment of a force, a moment of a force is the turning effect of a force around a fixed point called pivot, or you simply have this formula. The moment of force is force multiplied by perpendicular distance from the point of action on the body. So once you do that, you will have done a very good justice to the definition of moment of force. The diagram on the other side shows a pivot point, a body on a pivot here. Now this body, a moment will occur once this force acts on this, and the force is enough even to tilt this object to this side. So if we are now going to calculate the moment on this force, it will be force here multiplied by the perpendicular distance. It will give us moment of force around this point. Moment of force around this point. Now let us see some example here. The question here says, If you apply a force of 25 Newton to the end of a 10 centimeter long spanner to turn a knot, we can find the moment of force as follows. First, we convert the centimeter into meters. It is very important for us to take note of this. Whenever we are given a question and the unit of measurement is in centimeter, we must convert it to meter first, because the unit by which the calculation will be expressed at the end of the calculation will be in meters. So now we'll convert this 10 centimeter to meter. When you want to convert it to meter, you divide it by 100, because 100 centimeter equals 1 meter. So we should take note of that conversion. Then when you have done that, recall that we said that moment of force is force multiplied by the perpendicular distance. Now from the question, we are given 25. We are given 25. 25, this is 25 as the force that is acting. We are given 10 centimeter, that's the perpendicular distance. We have converted this 10 centimeter to meter, which gave us 0.1 meter. And this is the formula that we are going to be using to calculate it. So all we need to do is just plug the value into the formula. 25 comes here and 10 here, which is the same thing as 0.1, because we will have converted it to meter. Then we'll be able to get our answer as 2.5 Newton meter. So this means that the turning effect of the force on the knot is 2.5 Newton meter. Now, assuming that we want to increase the moment, that is, we want to exert we want to increase the moment, you can either increase the force or use a longer spanner. Now let us consider this example, that if we increase the length, observe that it is only the length that we increased. The force that is acting on it is still the same. Now if we plug that value into the formula, we are going to convert the 20 centimeter to meter, and that will give us 0.2 meters. Then we plug in the 25 Newton force that is being applied. You see that the moment of force has increased to 5 Newton meter. That is 2 times what we got initially when the length was 0.1. So if you want to increase moment of force around an object, maybe you want to lose a bolt in your car now, and you are applying, maybe your energy is not so much and you are trying to loosen it and it's not being loosened. All you need to do is, if you don't want to increase the force that you are applying, just increase the length of the spanner which you are using. And once you increase the length of the spanner, you will see that you have much more force even to turn the knot. So this is what majority of our mechanics use. You must have observed them when they are losing knots of their vehicle. You just observe that they increase the length of the spanner that they are using. Can you see this one using a longer length of spanner? Can you see this one too, a longer length of spanner to lose the knot of the tire? So that is how you apply the moment of force in our day-to-day activity. So I will, in the course of time, I will give you enough examples so that you will understand this concept better. Now the next one we'll be considering now is rotational motion. Rotational motion is the circular motion of an object about an axis of rotation. Now circular motion is when an object moves in a circular path. Example of circular motion is a roller coaster. When you go to playground or amusement park to play, you see a roller coaster taking the children just rotating like this. Is an example of an object moving in a circular motion. Another thing is a toy that is attached to a string and you are now swinging it in a circle above your head. just like that, swinging it above your head is also an object in a circular motion. Now, when solving problems involving rotational motion, we use variables that are similar to linear variables like distance, velocity, acceleration, and force. When you are calculating whatever it is you can calculate in a linear terms, you can also calculate those things in a rotational motion. But the difference is that in rotational motion, they take into account the curvature of rotation. Here we define angle of rotation, which is the angular equivalence of distance, and angular velocity, which is angular equivalence of linear velocity. So when you talk about angle of rotation in rotational motion, what it means in linear terms is distance. In linear terms, it means distance. When you talk about angular velocity in linear terms, it means linear velocity. When you talk about angular acceleration in linear terms, you are talking about acceleration of the body. Now, pay attention to this information on the screen. Now, angular rotation, if you want to calculate it, it is arc length divided by the radius r. Now, when we are talking about revolution is the motion of an object in a circular path from the point where it begins to the point where it ends. Now, one revolution is 360 degrees. Now we are talking about one revolution, it is 360 degrees. Now, if you are going to express this in terms of radian, you say it's 2 pi radian, 2 pi radian, 2 pi radian. That is what it means, 2 pi radian. 2 pi radian is equal to 360 degrees. So when you are seeing a circular motion from beginning, let's say beginning is A and it moves round and it comes back to A, it has done one revolution and that is 360 degrees, and it is also called 2 pi radian. So now when you want to calculate angular velocity of it, you know that velocity in linear time is distance over time, right? Now, in angular time, velocity will be angular displacement over time. Can you see the similarities now? Angular displacement over time. That is the angular velocity. That is what it means. And that angular displacement is here. That is the angle it moves from point A to point B. That is your angular displacement. And you divide it over the time it took for it to achieve that distance from point A to point B. Now, there is a formula here that you need to pay attention to. Now, if you want to calculate your angular displacement, you can calculate it by using this formula, the length of this arc divided by the radius of that circular motion. That is what you use to determine the angular displacement. And when you've gotten the angular displacement, you just come and plug it into the formula of velocity. Then you'll be able to determine your time taken. Now, the next one is tangential velocity. Tangential velocity is the instantaneous linear velocity of an object in rotational motion. So, tangential velocity is when this body is moving in this is moving towards this direction. So the tangential velocity is something that comes like this. So it is the tangential velocity that will now translate to linear velocity by which this vehicle is moving. So if we are going to calculate the tangential velocity, we are going to take the arc length into account and the time taken, just like we show in this place. That is angular displacement over time taken. and we talk about this one as arc length, that is change in s over the time taken. And now they want to, this formula want to relate this tangential velocity to linear velocity here. So in order to correlate it to linear velocity, now there is a substitution of equation in this place so that we'll be able to get this value, and then we'll be able to represent tangential velocity in terms of linear velocity. Now see the equation they use. They use the arc length formula, came up with the angular formula. They use angular formula, came up with the arc length formula. Then they substitute this arc length formula into this equation. Now when it is being substituted into this equation, then they are able to get the linear velocity equivalent of it here. Now recall that this formula W here is angular velocity. Recall that that is the angular velocity, and to know the angular velocity, we say the angular distance over time, right? We say is angular displacement over time. So we substitute this into this value. So that is why we are able to get r to change to angular displacement over time, and angular displacement over time is angular velocity. So angular velocity multiplied by r, that is how we got this. Now what is important for you to know here is that when you want to express angular velocity in terms of linear velocity, W, which is the angular velocity, you want to express it in terms of linear velocity, it will be linear velocity divided by the radius of that circle. Same, that is how to get it. Whatever the angular equation is, then you divide it, you bring linear equation, linear representative of it, and you divide it by the displacement or the radius of that circle. If it is acceleration, acceleration is equals to for a linear body is velocity over time, right? So if you want to calculate angular acceleration of a linear body, it will just be acceleration of a linear body divided by the radius of that body. So that is how to determine it. And then we talk about the angular acceleration, as change in angular velocity over time taken. Then we talk about the frequency. Frequency is the number of cycles that you are able to complete within a second. So the formula is number of cycles divided by time. Then we talk about period. Period is how long it takes to complete a revolution, to complete a cycle. So that is 1 over frequency. So if you understand all these concepts very well, you'll be able to apply them in whatever questions that comes. Now let us do this question before we progress. Let's calculate the angular speed of a 0.3 meter radius car tire when the car travels at 15.0 meter per second. That is about 54 kilometer per hour when it is being converted. Now if you want to solve this kind of equation, the first thing you should do is, what are the parameters that are given to you? The first of the parameter is the radius, which is 0.3, so you bring it out here. Then you are given the velocity. you bring it out here. So what are you asked to calculate? That is angular speed that you are asked to calculate. Now, in order to calculate the angular speed, remember that I told you that when you are calculating the angular equivalent and you are given the linear equivalent of that equation, all you need to do is just divide it by half. Now you are given speed, which is the linear equivalent of angular speed. You are given that already. So all you need to do is your angular speed will be equal to linear speed, which is 15, divided by the radius, which is 0.3 meters. Then you will get your answer, which is 50. I hope you understand that concept. Whenever you are given a linear information and you are asked to calculate the angular equivalent of it, all you need to do is just divide that linear parameter that is being given to you by the radius of the rotation. So once you do that, you will get your answer, and it will be expressed in radian per second. That is why you have rad per second. So you should take note of that information. Now the next topic we'll be talking about is centripetal and centrifugal force. Now when you are moving in a car and you are negotiating a roundabout, you discover that when the car is in constant speed and you are moving, you hold the steering still, you discover that you will be sliding, you will slide on the seat of the car. Now what is happening is centripetal and centrifugal force acting on your body. So centripetal acceleration is the acceleration experienced when in a uniform circular motion. And centripetal acceleration force is a center-seeking force. That is always seeking the center of a body. So centrifugal force is a fictitious force that acts in the direction that is opposite to centripetal acceleration. So that's just the simple concept of centripetal and centrifugal force and acceleration. And this formula is what you use to determine centripetal and centrifugal acceleration and force. Now for centrifugal acceleration is v squared over r, and which in angular terms we have the radius multiplied by the angular velocity square. So and for the force, force is mass multiplied by acceleration due to gravity. So the acceleration due to gravity, if you substitute it, you have m into v squared over r, and which also can be referred to as mass multiplied by radius and a square of angular velocity. Now let's consider torque and total mechanical energy. When we are talking about torque is just angular force, so to say, a force that is applied to a body in rotation. That is what torque is all about. And the formula for calculating torque is the radius of that rotation by multiplied by the force that is applied perpendicular to the pivot points of that circular motion, and multiplied by the sine of the angle of application. And majorly, most times the angle of application is perpendicular to the pivot point, so it's most times 90 degrees. That is pi over 2 radian. And the total mechanical energy in the body is the sum of potential energy P plus kinetic energy Ke. And for potential energy, in order to calculate it, is mass multiplied by gravity multiplied by the height of the body. And for kinetic energy is half 1/2 multiplied by the mass of the body multiplied by the square of the velocity of the body. That is the summation of these two energy will give the total mechanical energy in a body. So this is an example to discuss the concept of torque very well. Now consider a man that is pushing the playing ground merry-go-round. Maybe a child is sitting on the merry-go-round and the man is pushing it. Then he exerts a force of 250 Newton at the edge of the merry-go-round and perpendicular to the radius. The force is exerted at the edge and it is perpendicular to the radius or the pivot point here. And the radius is 1.5 meter. Now, how much of torque does it produce? It's asking that how much of force is being applied to move this merry-go-round, to make it move. He said we should assume that the friction acting on the merry-go-round is negligible. That means there is no friction. The total force that is applied is making it to move, and we will get the torque that it produces. Now, when you are given this kind of equation, like I said the other time, the first thing you will do is what are the parameters that are given. So what are the parameters that are given? Now, in order to determine the parameters, the first one here is force. The force is applied. You said F is what? 250. The next parameter that was given is 1.5 meter. That is the radius. You put the radius. Then what you are looking for is the torque. Now, if you apply it to the formula that is being given, what is the angular displacement there? We said it is perpendicular, which is 90 degree, and 90 degree is pi over 2. Pi over 2. So now, if you apply that parameter given, you supply it into the equation, you have something like this. The radius is 1.5. You send it there. The force that is given is 250 Newton, and the angle of rotation 90 degree. Now, sine of 90 degree rad of sine pi over 2 is 1. So if you multiply this 1.5 by 250, your answer will be 375 Newton per meter. So on this note, we have come to the end of this class. I want to encourage you to make sure that you look through your lecture notes and go through these things that I have explained. So I believe that when you go through them, you will get the concept even more better. Just spend few times or some hours going through your note and understanding the concept that is being discussed. Thank you for listening. See you next class.